Inverse functions is the title of our notes, and here's our notation. Now, you want to be really careful about how you talk about this. This is titled as f inverse of x. Please, for the love of math, do not say f negative 1x. That makes you sound super lame. It's f inverse of x. That's our notation. So there's a couple important things about inverses. The first, inverses have their x and y swapped. Hence our conversation today about wife swaps.
Is it over?
Yeah, it is. I figure it's probably worse to put it on YouTube, but here we are. Number 2, inverse functions cancel out.
Bryce,
No.
can you please stop making that noise? Yeah. Thanks.
That was nice and forward. All right, let me give you an example. X squared, let's let that equal to f of x. And who knows the inverse of an x squared function? Square root of x, you did it. Perfect, those are inverses. Now, why is that true for 1? Well, let's get some coordinates here. If I had an x value of 3, what's 3 squared? 9. And if I had 4, what do I have here? 16. Okay, now let's go to this function. What's the square root of 9? And what's the square root of 16? Do you see how the x's and the y's have been swapped?
Wait, where are we getting the?
Where am I getting the?
Oh.
So I've just kind of proven to you that they're inverses if your x's and your y's are the same, but they're different location, they're swapped. The next thing is they cancel. If I look at the square root of x squared, what does that give you? X. It cancels out. The squared and the square root cancel. What if I had the square root of x being squared? What do you get? X. Right? They cancel out. A square root and a square, they disappear. You can almost kind of go like this, and you're left with just the x. You can go like this and the squared, and you're just left with x. So they're inverses. Do I really at this point care that you know too much about this? No. What I really care about is that you know how to find the inverse. And so that's what we're going to cover right now. So I have 3 steps for you. I want you to get them down. And then we're going to try to tackle this problem. They're not bad at all. Okay, here are your 3 steps. Get those down, please.
Sorry, yes, sir.
Ready?
Yes.
Okay. Let's do A and then figure out if you want to do B. So first of all, we're trying to find the inverse of this function, and we're going to follow the steps on the last slide to do that. Because I swapped slides, can you guys tell me what the first step said in your notes? Perfect, replacing f of x with y. Let's do it. check, done it. Next step, wife swap. Okay, so now we're changing the y to be an x. Changing the x to be a y. Plus 1. What's the first half of the next step?
Solve for y.
Solve for y. So we're gonna subtract the 1. That gives me x minus 1 equals minus 1 over 2y. And now, if I want to get rid of a negative 1/2, I need to multiply by its reciprocal. So what would I multiply both sides by? Just positive, negative 2, because you wouldn't want a negative times a negative to give me positive. So we're going to multiply this whole thing times a negative 2, which means I have to multiply this whole thing by negative 2. So I've got a negative 2 times a negative 1/2. Well, a 1/2 times a 2 is a positive 1, and a negative times a negative is positive, so these two things cancel. And I'm just left with y equals negative 2 times x minus y. Do you want to do distributive property, or do you want to leave it like that? Distribute? Okay, so I'm going to do y equals a minus 2x plus 2. Last step in step 2. Last step in step 3. Change my y to be f inverse of x. And now we're done. Would you like to do one more at this level, or would you like to do one with square roots? One with square roots. Do we want to do B? Anyone want to do B? Okay, let's skip to C then. So all I've done is just rewritten the fx as saying y, and then I swap my x's and y's, and then I solve for y. That's it. Now let's make this problem a little harder. Let's go to C. F of x equals the square root of x minus 2. Now some of you might want to kind of almost step over the first step, but if this is going to say y equals, what am I going to rewrite this as right here? X, wife swap.
Awkward.
Why don't they do dad swaps? You've never seen the TV show?
Oh, no, it'd be husband swaps.
Oh yeah, that's true.
Because then the wives would just have different dads.
What?
If we did dad swap?
No, I see what you're saying.
Yeah, okay.
No, there's like literally 9 seasons of it.
Is it good?
It's offensive. All right, so I've got x equals the square root of y minus 2. What would I do to both sides here? Square. So I'm going to square that, and I'm going to square this. So that gives me x squared equals, and then I get y minus 2 because my square root and my square
Plus 2.
cancel. Then you add 2 to the other side, like Sam just said. You get x squared plus 2. Final step is to rewrite the y as f inverse, so our final answer is f inverse of x equals x squared plus 2. How do we feel about this? Okay, go to your last homework. And you're going to be doing the last 4 problems. I'm going to do them on the board with you so you can check your work as you go. But you're working on those last 4 problems. Yep, should say, is it problem number 5 with 1, 2, 3, and 4?
It's kind of weird. something. Good luck.
Beat me. Okay, only thing I didn't really mention in our notes was that if you're trying to get rid of something to the fifth power, you would fifth root it. Just like if you had a squared here, you would square root it. And then similarly down here, if you have a cube and you're trying to undo the cube, you would cube root it. Ready to move on?
Ready to move on.
Here we go. Moving on like a herd of turtles.
You gotta come up with another saying.
How about a group of octopus, an octopi?
There actually is a name for that. I think it's a pod.
A pod of octopi.
I think pod is for whales.
Yeah, it is. I think it's the same though because I remember learning about it.
Who has the most useless knowledge base in this class?
It's gotta be me. I have like facts that will never.
Give me one.
Okay, hang on. You have to ask me a topic.
Okay,
I'm
how
sorry.
about fish facts?
Okay. Hatcheries around the world,
Uh-huh.
mainly in Washington.
Really?
This is some insider knowledge actually.
Oh, wow.
Are being accused of not clipping all their released hatchery fish to make their numbers look better. It's actually a huge issue, and they're getting really heated with the WDF and W about it.
Very
There
interesting.
we go.
They're trying to prove that there's more wild fish than there actually are.
Yeah, because hatcheries are supposed to bring more wilds back than they are
Interesting.
do anything.
Very interesting.
Yeah.
Okay, moving on to transformations. Title of your notes, transformations. We have learned 4 out of the 7 things on the board. I'm not gonna say, I don't think you should put this chart down. It just takes too long to write, because there's only 3 things that we need to know from this that we don't. I want to review with you the first four that I'm claiming that you know, and I'm going to prove to you right now that you do know them. So, I've told you this problem many times before. I've done it with you many times before. I would ask something like, is it left, right, up, or down? So in this case, in the parentheses, it's opposite of what we think. Is this going to be left or right? Right. This one's right 3, and what is this? Up 2. How about this one? And down 1. Okay, so the inside the parentheses is left and right. It's opposite of what you think. Outside the parentheses is up and down. It's exactly what you think. So that's the +2 example. That -c is that example. That example is here. And the -c example is there. Okay, moving forward with that. Let's now deal with the last 3. And I can prove the last 3 for you in 2 problems. Let's do y equals -2x squared.
Write this down.
Yes, please. And then let's also write down y equals 1/2 x squared. What is true about a quadratic with a negative in front of it? It's a sad face. In fact, I really like what Gabe just did. So everyone put your eyes on the board. He went like this. He was like, it did this.
Oh wow, that's beautiful.
Yeah, thank you. And so this negative causes the parabola to go from here to here, which is a fancy way, or not fancy way of saying reflecting over the x-axis. Okay, so I want you to point to this negative. Because of that negative, our graph has been reflected over x-axis. There's something else that's happening to this graph, and I want you to ignore the negative. The next thing I want you to do is point to the 2. Don't say -2, just say I'm pointing to the 2. We've already dealt with the negative, it means reflected over the x-axis. And so if I were to draw this graph, if I had my original function x squared, what's happening is my graph is getting narrower with the y equals 2x squared. So the purple would be y equals 2x squared, and the red's x squared. So looking at this right here, hey, if I have a number that's greater than 1, that means I have a vertical stretch. So watch this. I'm taking my purple graph, I'm putting my hands here, and I'm vertically stretching it. So, I'm taking my red graph and I'm vertically stretching it, and I'm getting the purple graph. So I'm vertically stretching, it's making it more narrow. So we should point to the 2, and we should say that this is a vertical stretch by 2. We're literally taking this red graph and we're vertically stretching it, and it's becoming that purple graph. Anything you'd like to add to that?
No.
Want to say something to the blog? Oh, whoa. What
You're
the?
being recorded.
Oh, really? Right now?
Yeah.
Oh, well, that changes everything.
Chris was a doctor.
All right. Next up, let's talk about the 1/2. If I have a number that's between 0 and 1, basically, if I have a fraction, ignore the negative. If I have a fraction like I do here, then it's been a vertical compression. Again, everyone put your eyes on the board. If I had this original red graph and I wanted to 1/2 x squared it, what's happening is you're taking this red graph and you're squishing it down like that. You're vertically compressing it so it becomes that. So I want you to point to the 1/2, and this is going to be a vertical compression by 1/2. It's been smushed. You don't think Deputy Hunter wanted to learn about transformations?
I think he has something to hide. That's why he ran.
Okay, I just want to show you some more visuals, and then we're going to do 4 problems together, and then we're moving on from this topic, and you can do your worksheet. Notice how this is my parent function, and as soon as I +3'd it, it went up 3. If I have absolute value of x and I put something inside, that would be a -2, so it's actually going right 2. So we've seen that before. Notice how as soon as I put a negative in front, my graph is being flipped over the x-axis. So it gets flipped. You guys like that? And then last but not least, if I have a number like 3, my blue graph is my original, I'm stretching it, it's a vertical stretch of 3 and it's getting narrower. If I have a number like 1/2, I'm actually taking my red graph and I'm smushing it to be the blue graph. So here's what these problems are gonna look like. Take a minute to write down problems 1 through 4. Leave enough space that I can write a full sentence below each. Okay, so maybe even 2 spaces. Get those 4 problems done. By the way, we have 5 challenges before our competition's over.
When is it like come up? Tuesday? Is what doing now before our final or after we already got our?
I think before, we'll do before.
Cause they.
Have the
well,
post
they
been
guess
graded
one
yet?
doesn't-
No, because Cromwell was out sick.
Oh.
Cromwell sick.
Apparently.
Time for anarchy.
Miss Cromer, come back. No, she's probably sick. She's a ethical human.
Kidding, Cromwell, just because it's on video, I would never ever cause anarchy in your absence.
Also, I would never question whether you're sick or not. I'm sure you're very sick.
Continue.
This is going downhill fast.
This is going on long.
Just like to say, I think you're a great principal.
Best boss ever.
Yes.
All right, let's do this. I want you to point to the negative, and the negative tells us that this function is
Reflected over
going.
the x-axis.
That's right, reflection over the x-axis. I'm all about abbreves. Okay, the 2, is that going to be a vertical stretch or a vertical compression? It's what you think it is. Yep, it's a vertical stretch because that number is bigger than 1. So it's a vertical stretch by 2. Last but not least, we have a +4 on the outside. Is that left, right, up, or down? Up 4, perfect. Okay, next one. We don't have a negative, so there's no reflection. But the 2/3, it's gonna be a vertical what? Compression by, good. And the reason I knew it's compression and not a stretch is because 2/3 is a fraction. Left, right, up, or down 2?
Yeah, too.
Right 2, and then up 5. Okay, this negative, Sam? Give me
That means it's going to be reflected over the x-axis.
with a star. Okay, the 4. Vertical stretch or compression with the 4? Vertical stretch by 4. It means this graph is pretty narrow. And then this right here means it is up 2. Last one. The negative is,
Reflected over that.
yep. Okay, then we have a 1/2, which is a vertical compression by 1/2. I mean, it's been smushed by a half. And then the +4 on the outside is a up 4. So you feel like you can do the first part of your homework, which I've not handed you?
Yeah.
Perfect, getting back to you now.
We'll have to see it.
Okay, if anyone can do it, it's you.
Actually, totally.
Finish early. There's a picture of a half-drawn horse on the back, which you can complete.
Ooh, this is fun.
Oh, that's right, cat.
No, I'm not gonna ask you.
Appropriate?
Yeah, yeah. I don't know what you would think about it. Hey, plug it. Plug this.
Log it?
Yeah.
Can I spin it? Hold up, Ash. We're gonna move your view a little bit.
Hey, you get on.
Christmas or Black History Month?
Christmas.
Yeah, I like it.
Because I get presents.
What about Black History Month?
Exactly.
It's very important, very important. But did you ask if I like it better or?
Like, what to stay? Which one would you rather have stay?
Oh, then Black History Month for sure.
Why?
Because I don't need anything for Christmas, and to me, Christmas is just a gimmicky holiday that's really fun.
She's
But-
lying, guys.
Black History Month
No,
is
actually, that's a very good.
But
That's,
Black
you know, that's a
History
hard question to be posed, and I think you answered it very well.
And now your answer's going online.
I thought you meant, like, in terms-
Washington's teacher says.
I think it means in terms of like what you
shit.
enjoy.
Oh, not.
If I definitely enjoy Christmas more, but in terms of which one we would get rid of, I would definitely get rid of Christmas over Black History Month.
We're on TikTok. Wait, which is a, oh, this is a fact.
We got another random fact, actually,
Okay.
about Black History Month. Morgan Freeman does not like Black History Month, and
I did
even
know that.
even said so on air.
He said we should stop
Jewish,
talking
yeah,
about
he said, would you rather have, would you like, he was asking a Jewish guy if he would want a Jewish History Month, and the guy's like, well, no.
Shall we?
No.
Okay.
Okay, one more minute. We got 2 more topics today. We're gonna go from easy to medium.
Are you predicting some free time in our future?
Not today.
Maybe 5 minutes at the end here, maybe 7. Still, I hope you feel better. Sorry to hear about your leg.
That's a good looking horse.
To be clear, Sam is laughing about a horse and not.
Oh,
about
yeah,
your
yeah,
leg.
yeah, so I feel terrible for you. But mainly I miss Ashton. I want you back, buddy.
I think that's that.
All right, we're gonna move forward. Go ahead and tell you it's the average rate of change. And go ahead and get this table down. Basically, let's say Bryce is going on a road trip, and after 1 hour, he's averaged 40 miles per hour, and then by hour 2, he's at 45 miles per hour, at hour 3, etc. So get that down, then we'll talk about what the question is asking. Kind of dry and mediocre. It was okay. I made the crust myself, and it's just, I'll just get us some normal. I crust you guys. Oh, yeah. I'm glad you ordered. Okay, what is the question asking? It's basically saying, on average, per hour, how many miles did he increase? And so here you can see that he increased 5 miles. Here he increased 10 miles. Here he increased, what was that, 7. Here 13. Here 7. So like on average, what was his increase per
7.
hour? Yeah, maybe around 7. I think that's a good guess. So what we're gonna do to find the average rate of change, or the average change in speed, that's a fancy way of saying find the slope. is gonna be the slope equation, which is change in y over change in x. So go ahead and add to your table arrows in this direction. We're gonna do 82 minus 40, those are my y values. And then you have to go in the same direction and do 6 minus 1.
This is the most useful thing we've done all year.
Oh wow. 82 minus 40, and then 6 minus 1. And so, just be careful in your calculator to make sure you put parentheses or you do the alpha F1 thing, but I'm just gonna do 82 minus 40, which gives me 42 over negative 5 equals negative 8.4, or positive 8.4.
Cause 6 minus 1 is
Thank you. And so Sam's guess was 7, and it was a good one. He's saying on average you're going up 7 miles each hour, but it ended up being around 8, which is pretty close to his guess. Now, how are we gonna do the units? What were the units for the y value?
Miles per hour.
Okay, so we had miles per hour here,
Dang it,
and then
Bruce.
what were the units for my x values?
Oh, that was his retainer. It's on the ground.
Ow.
Don't put it in your mouth.
So we are increasing 8.4 miles per hour. Does that make sense? We're increasing about 8 miles per hour each hour. Gentlemen, that makes sense? Mile per hour, so we're going up about 8 per hour. We're increasing 8 miles per hour. Do you want to do another one of these, or I think you can do the
No,
one on
actually,
your
I feel
worksheet?
really good about this.
All right, go ahead and tackle this one. And then we have one more topic left to end our day. I got a joke for you guys. So the other day, my neighbor said, "Hey, hey, did you see the cat bowl?" And I said, "No, I've never seen him do sports."
Well, guys.
The setup was funnier.
Hey, have you seen the cat bowl? No, I've never seen my cat do sports.
Oh, I get it. Only for
Do
2
another joke?
Another joke for you. The other day, Sam stole my thesaurus. I was flabbergasted, aghast, horrified, and petrified.
Yeah, 'cause she stole it.
Those are all synonyms. No, not a good one?
No.
I tried. Y'all ready for the last topic of the day, and then you'll have your free time?
Oh, yeah. Oh, yeah.
Mate, it's your very own problem.
Yay.
All right, last problem of the day. This is called the savings problem. I'm gonna ask you not to write down the whole thing because I can just write down information in 2 points and you won't need to write this all down. But let's read it first.
Should we write savings?
Right savings problem, yep. So May is gonna save up for a trip to Cancun. She's gonna show her wild side. After 3 weeks, she's saved up $400, and after 6 weeks, she's saved up $600. We're assuming she's saving up with like a constant rate. First, you have to write a linear equation that expresses the money that she's saving versus the time in weeks that it's taken, and then you're gonna figure out how many weeks it's gonna take her to save $5,000. And so the reason I said don't write down the problem is because we can just write these as coordinates. So 3 weeks, $400. So we're gonna write this as 3 weeks, $400. And then we're gonna write this as 6 weeks, $600. And now we have to create an equation for those 2 points. Basically, we're trying to find a line of best fit. That's really what we're doing. So let's just go ahead and find the slope. So slope is equal to change in y over change in x. It's literally the exact same thing you just did. So we'll go 600 minus 400. And then 6 minus 3. Can someone get that answer for me? I think it's like 66.66, but I need someone to confirm. Yeah. 66.66.
Number of these.
I think it's the devil, not
Yeah,
the
that's what I
beast,
said,
yeah.
number of these.
Alright, so now we're gonna create an equation, so we're gonna write down your favorite equation, y equals mx plus b.
That's just like, that is like math, peak math right there.
Yeah, if there's one thing you've taken from math, it's y equals mx plus b.
Thank you, Ms. Johnson.
Alright, now, instead of putting a y here, let's choose your favorite coordinate. Do you have a favorite coordinate over here?
7.
There's no 7 here. Choose which one, the 3, 400 or the 6, 600?
3, 400.
Alright, so we're gonna put an x under here and a y. Which means over here, what am I gonna put in for y? 400. Everyone see what we're doing? We're just plugging in. What did we find my slope to be? Yep, 66.6. What's my x value of the coordinate we chose over there? 3. And then we say plus b. We have done this last year. Not the same problem, but the same concept. So I think that's 200, but can someone confirm with me?
100.98, so.
Okay, so we're gonna have 200, because we just did that math.
200?
200. Okay, then I'm gonna subtract 200 from both sides, and I get 200 equals b. So I have now created a linear equation, but I've gotta write it out completely. It's gonna be y equals my slope, which is 66.66. And then it's gonna be plus 200. So where'd I get the m from doing change in y over change in x? This was my slope, mx plus b. Where'd I get the 200 from? From plugging in the y and the x from that original coordinate, and then just solving for what b is. So we're halfway done, we're done with half the answer. And so, what is this saying? This is actually saying that May started with $200 in her bank account, and she's getting $66.66 each week. Yeah. Now we're trying to figure out how long it's going to take her to save 5,000. So which number here do I let equal to 5,000? Y. So I'm going to set this to be 5,000. And I want you to solve that equation for me. I get 72. So my other answer is going to be 72 weeks. Do you feel like you want to do another one of these problems?
No.
All right, then let me just quickly restate how I did this. So everyone pay attention for one last second. First step, write your 2 coordinates. Next step, find your slope by doing change in y over change in x. That's 600 minus 400 divided by 6 minus 3. Please go in the same order. Once you get your slope, write y equals mx plus b. Plug that slope in right here. Then take your x and your y, put your y in, put your x in, solve for b. Once you have your b, you have your equation because you've already found your slope and you found your b. So that's your first answer, and then set that equal to the money that she wants to save up. Subtract the 200, divide by 66.66. Okay, you got 2 problems to do. Thanks for watching. Hit like below. It's subscribers like you that really make a difference.
Are you gonna put an ad in this thing?
Juicy fruit gum makes your mouth happy and clean.
No, wait, water.